Bismillah ar-Rahman ar-Rahim. Hello everyone. Today in this lesson we're talking about finding the critical point increase and decrease region. First, what's the critical value? What's the critical value? X equal to C is a critical value if satisfy two conditions. The first condition, X is equal to C, it must belong to the domain of function. The second condition, f prime of C equal to 0 or f prime of C is undefined. Okay. Let's go to this example, the first example. First step to finding the critical value, take the derivative of function, okay? Derivative of function. This is first step, take the derivative of function. Second step, set f prime of x equal to 0 to find the value of x. If x satisfies these two conditions, then x is critical value. Take the derivative of function, f prime of x is 2x power 1. Negative 6x, because it's a linear function, we take only 6. Then this is first step. The second step, let f prime of x equal to 0, then 2x minus 6 equal to 0, transfer 6 to right side, divided both sides by 2. Okay, x is 3. X is 3 is a critical value? Yes. Why? Because 3 is belong to this domain of function. The domain of this function, all real number, because this function is a polynomial function, then 3 is belong to the domain. And 3 in f prime of 3 is 0. Then x equal to 3 is a critical value. After critical value, if we want to find the critical point, okay? If we want to find the critical point, replace this x equal to c at the function x equal to 3. We have f of 3 squared minus 6 times is it? 3 is a negative 9. Then 3 and the negative 9 is a critical point. To finding the increase and decrease region, plot this 3 on number line. We have a 3 and plot in number line from negative infinity to positive infinity. In this neighborhood, choose any value less than 3. For example, I give you the value of 3, 0, less than 3, 0, more than 3. For example, 4. And replace 0 and 4 in f prime of x. The f prime of x is 2x minus 6. F prime of 0 is 2 times 0 minus 6. We get negative. When we get the negative in this region, this interval is decrease. Evaluate the f of 4 is 2 times 4 minus 6 is positive. Then this region is positive. We have increase region or interval. Okay, what's the type of the critical point? In the critical point, we have three types. The first type is locally max, when we have this shape, like this, is a locally maximum. Locally minimum, when we have this shape. Only critical point when we have two neighborhoods, both of them is increase or decrease. In this case, we have the shape, this one, then this point is locally minimum point, this type of critical point. Right? The increase and decrease region, increase region and decrease region. First region in the left starts from negative infinity until 3. Always is open, or always the interval increase and decrease is exclude. Okay? Increase region starts from 3 to positive infinity. Okay? Let's go to the second example. Okay? To second example. We have this example. Okay. First, take the derivative of function f prime of x is 1 over 3. 3 times is 1 over 3. And x squared minus 2 times is 3 over 2. X power 1. 9 over 2 is constant. The derivative of constant is 0. Simplify 3 with 3. F prime of x is x squared, and 2 with 2, numerator and denominator, we get 3x. Let f prime of x equal to 0. Then x squared minus 3x is 0. To solve this equation in degree 2, first step, take the common factor. The common factor between x squared and x power 1, we take the smallest power. Then we have x common factor. The remainder is x in first term, and in second term is 3. Then use the zero product property to solve this equation, or use the OR. X equal to 0 or x minus 3 equal to 0. Transfer 3 to right side, we have 3 positive. The domain of this function, this is a polynomial function. Again, this domain is a real number, like the first example. Okay? Then 0 and 3 are critical value. To finding the critical point, replace 0 and 3 in the function. 0. We replace 0 first. F of 0, 1 over 3, 0 cubed, minus 3 over 2, 0 squared, minus 9 over 2. We get negative 9 over 2. Then 0 and negative 9 over 2 is critical point. Okay? Replace 3 in the function, f of 3. We get negative 9. You can calculate this value by using the calculator. It's easy and faster. F of 3 is negative 9. 3 and negative 9 is critical point. Okay, to finding the increase and decrease region, use the number line. negative infinity to positive infinity. Plot 0 and 3 from smallest to biggest in the left to right. First use the 0 or plot the 0, second 3. Okay. Less than 0, we take -1, -2, -3. Between 0 and 3, the value give me the value of number 1. For example, 2 is also you can use. Bigger than 3, 4. Okay. Do not forget, okay? You must replace -1, 1, and 4 in f prime, not f. Okay? In f prime to this point, the sign of this region. F prime of -1, f prime of 1, f prime of 4. Teacher, I can solve this faster. I have new idea how you can use the graph of function. For example, this function is cube and positive. The graph of this function cubed with polynomial is like this. If like this, then this region is increase. This is increase. This means that this positive. This region is decrease. Then the sign is negative. The third region is increase also as a positive. Then we have increase, decrease, increase. This point with 0, the x is 0, is locally max, the type of this point. And the second point, 3 and -9, is locally minimum point. Okay? You can written the increase region is a start from negative infinity until 0, union 3 to positive infinity. Decrease region is less between 0 and 3. It's less between 0 and 3. Open interval 0 and 3. Okay? Let's go to another example. Okay? This example. Okay? We have fraction. In a fraction, it's necessary you must finding the domain of function. The domain of this function, all real number beside the -1. All real number beside the -1. Then x equal to -1 is not critical value because it's not belong to the domain, because it's not satisfy the first condition. Okay? Find the f prime of x. You can use the cross product way. It's easy. First, start from down, x plus 1, and take derivative of down is 1. And up, we have in up x minus 1. The derivative of x minus 1 is also 1. And the cross product way is very, very easy. And x plus 1 times 1 is x plus 1. Okay, we write f prime of x is x plus 1. And second diagonal, x minus 1 times 1 is x minus 1. But you must take converse of sign. We have x minus 1. The converse of sign is negative. Is the negative x plus 1 over denominator square. The denominator square is x plus 1 square. Remove negative x with x. We get 2 over x plus 1 square. When we have a fraction, the numerator equal to 0. is not possible because 2 is not 0. Let the denominator equal to 0, x plus 1 equal to 0 square. Any base or any parenthesis with any power equal to 0 directly is inside is 0. Then x plus 1 is 0, x is negative 1. Is negative 1 critical value? No. Why? Because it's not belong to the domain. Then we haven't the critical point. If you haven't critical value, then we haven't critical point also. But you can use this value to finding or to disappoint the critical increase or decrease region. Use on number line from negative infinity to positive infinity, plot the negative 1, choose the number less than negative 1, for example negative 2, and bigger than negative 1, for example 0. And plot this in the f prime of x to now the sign of this region. F prime of negative 2 is always this derivative function is positive because the denominator is positive and parenthesis with power 2 is also positive. Then is in the result we have the positive in this sign, this region. Then this region is increased. And put or replace the 0 in f prime of x, then is also is positive. We have two regions increase, start from negative infinity until negative 1, union negative 1 to positive infinity is an increase region. As always is open or exclude the interval. Let's go to the final example. We have 1 over x squared. This 1 over square is always, when we start, we must disappoint the domain of this function because it's a fraction. Okay, to finding the domain of fraction, let the denominator x1 square equal to 0. Any base with power is 0, then the base is 0. The domain is all real number beside the 0. Okay? Then, find the f prime of x. F prime of x, negative 2 times 1, negative 2. And add 2 to 1 is a 3. Negative 2 is not 0. Why, teacher, you equalize the up to the 0? Because when we equalize the numerator 0, we want to find the f prime of x is 0. And in denominator, we want to disappoint which value is make f prime undefined. Okay? If x cubed equal to 0, then x is 0, but it's not critical value because it's not belong the domain. Plot on the number line 0, start from negative infinity to positive infinity, and use the negative 1 and positive in right. Okay, substitute in f prime of x. F prime of negative 1 is negative 2 divided negative 1 cubed is positive. This region is positive increased region. F prime of 1 is a negative 1, negative 2 over 1 cubed is negative. This is negative, is decrease. Then we have negative infinity until 0 is increase region, and 0 to positive infinity is decrease region. Okay, and we can answer this example by using the graph. The graph of this function is like this, okay? Increase from negative infinity until 0 and decrease from 0 to positive infinity. Thank you.